All right, we are going to do a few examples from section 4.4 on rate of change and constant rate of change. There are two things that we need to look at here. One is rate of change and the other is proportional and non-proportional. And I'm going to try and help explain the difference between the two of these as we move along. First of what we covered today was dealing with rate of change. In order to have a rate of change, we need to have two separate points because we have to find the difference in that change. So here I would find the difference between these 2 points. I know that the difference between 2 and 3, or 3 minus 2, is 1 because I just took 3 minus 2, and that would equal 1. Then over here I'm going to take 27 minus 8, and I should get 19, or just 9, because I should do my math right. So we'll just get 9 instead. And then I have to find what that is. So remember, we're going to take and we're going to put 9 over 1, and that would be the rate of change for this first set of points. So let's do it again here. We're going to take 4 minus 3, and that will equal 1 for this. Then we're going to take 64 minus 27. 64 minus 27 is going to give us 37. So when I write that ratio or rate over here, I get 37 over 1. I can already tell from this point that these rates of change are not constant. If they are not constant or always the same, then this is not linear. It is not a straight line if it does not have that relationship. If I wanted to determine if it was proportional, I am just going to look at its rate based on the numbers that exist. So I'm going to clear off our rate of change numbers here, and I am going to look at the proportionality. To find the proportion, I'm just going to compare these two. So I could put 2 over 8. 2 over 8 would be 1/4 reduced. Then I'll look at this one. 3 over 27. Well, this is 1/9. Are these ratios, are these rates the same? Nope. So that means that this is also not proportional. The big difference between the two is that this is just a single comparison of two values, and over here you needed to use two separate data points. So let's try a second problem related to this. Let's try this chair problem down here. First, let's start with our rate of change. In order to find the rate of change, again, I have to compare all of the values as I go down. I have to find their differences. So I'll start here, and I'm going to take 10 minus 5, and over here, 12 minus 6. In this case, I'm going to have, this would be 6, this would be 5. So I'm going to get 6 over 5, which is the same as 1 and 1/5. Let's do the next one. I'd have to find the difference between these two. So 15 minus 10 equals 5. Then find the difference between these two. 18 minus 12 equals 6. Looks like we've got the same ratio, 6 over 5. It's the same as 1 and 1/5. We can't always be sure just by checking 2 points, so make sure you check that final point. You never know if it's going to switch on you. And if they give you all the points, you got to take the time to do the work. So now I have 20 minus 15 equals 5. Sure looks the same. Let's make sure though. 24 minus 18 is a 6. So do these have a constant rate of change? Yes, they are all going to have 6 over 5 as their rate of change. If they have a constant rate of change, what does that mean? It means that it is linear, or a straight line. If I was to graph these points on a graph, it would be a straight line. Let's see if these are proportional. If it asks you that, not all of your questions ask you whether or not it's proportional. If it asks you whether or not it's proportional, you have to just compare the 2 points. I'm going to compare 6 over 5, which would be 1 1/5. And I'm going to compare 12 over 10. And if I reduce that, I'm going to get 6 over 5. I'm going to compare 18 over 15. If I reduce that, 3 goes into both of these. 3 goes into 18 6 times and into 15 5. And thus far, they all appear to be the same. Let's try the last one. 24 over 20. I know that if I divide both of these by 4, I will get 6 over 5. So those are also the same, which tells me that these are also proportional. Yes, there will be a time when it can be linear in a straight line, but the ratio over here for proportionality will not be equal. So make sure you're paying attention to that. The problems that you have are all related to charts and graphs and making sure that you just do all of the work. So do not be afraid to show all of your steps and do all of your work. Let's do one more here really quick. They give me the points 1, 2, 3, and 4, and they tell me that this is the time in hours that I work. They also tell me that I had helped a certain number of people. I had helped 12 people, 24 people, 36 people, and 60 people at a jewelry store that I worked at. I want to know whether or not this is a constant rate of change, and if it's a constant rate of change, it would tell me that this is linear. So again, I just have to slow down and do the work. I'm going to take these two and subtract them. 2 minus 1, it'll give me 1. And subtract these two. 24 minus 12, it'll give me 12. And I would find out that my ratio is 12 over 1. Let's try the next one. Here I'm going to subtract these two. 3 minus 2, that will equal 1. And subtract over here. 36 minus 24 equals 12. Again, I'm going to take these two numbers and compare them and get 12 over 1. Last but not least, again, you cannot stop. You got to make sure you check every single point. 4 minus 3 is 1. 60 minus 36. Does this equal 12? I don't think so. I think this would equal 24. So if I have 24 over 1, I can tell you that this is not linear. And the reason it is not linear is that the rates of change are different. So make sure you take the time and show each one of your steps. Good luck!